Hi, I'm Sean with LNC Math, and today we're going to be doing a video on radicals part 2, which is going to be focused on dividing with radicals and rationalizing the denominator. There are two ways you can do that when there's only a square root in the bottom, the denominator. You can either simplify and then get rid of the square root in the denominator, or you can do the opposite, which is get rid of the square root and then simplify. I'm going to show you both ways. For this problem, let's start with simplifying the bottom. Looking at root 8, we can simplify that to root 4 times root 2. Root 4 would simplify to 2, so square root of 8 is 2 root 2. Replacing this with 2 root 2, we'd get 6 root 2 over 2 root 2. Since these are the same thing and we're multiplying, these would cancel out. 2 root 2's would cancel out. And we're left with 6 divided by 2, which would be equal to 3. So that's one way. And the other way is we would get rid of the radical in the denominator first. In order to get rid of the root 8, we know that if you square a square root, it would cancel out and all that's left is a number inside. So to square root 8, what we would have to do is we'd have to multiply by square root of 8. To cancel the square root out. What we do to the bottom, we have to do to the top. And we can simplify this. Square root of 8 times square root of 8 would be equal to 8. And then 6 root 2 times square root of 8. We have to multiply what's inside the radicals, so 2 times 8 is 16. So we're left with 6 root 16. If we look here, the square root of 16 is equal to 4, so that would be equal to 6 times 4 equals 24 over 8, which still equals 3. And we get the same answer. Let's move on to the next problem. If we look at this one, we see that we cannot simplify square root of 3 or square root of 5 because they're not perfect squares, or they don't have any factors that are perfect squares. So since we can't simplify, we just have to get rid of the square root in the denominator. To do that, we would multiply by square root of 5 to get rid of the square root in the denominator. What we have to do, the denominator, we have to do the numerator. So square root of 5 on the top. So I'm going to move down here to show my work. So square root of 5 times square root of 5 would just be equal to 5 in the denominator. And in the numerator, we would multiply the numbers inside the radicals. So it's 3 and 5. Square root of 3 times 5 is 15. We keep the 2 right here because nothing happened to it. And if we look at this, this can't be simplified any further, so that's all we can do. That would be your answer. Let's move on to conjugates. Conjugates are needed when you have addition or subtraction inside the denominator of a fraction, because teachers and mathematicians do not like it when you have square roots inside the denominator of a fraction. To get rid of the square root, we have to use something called a conjugate. Now when I first looked at this, I was very confused, and I didn't get it until after a while, because if I tried to rationalize it like I did earlier by multiplying by root 2, if I multiplied this by root 2, that would become 2. But then you'd have to distribute it to also the 4. So that'd be 4 root 2, and that didn't solve anything because I still have a square root in the denominator. We have to use something called difference of squares, which states that a squared minus b squared is equal to a plus b times a minus b. I'll show that to you really quickly using FOIL. Now, if you don't know how to FOIL, this might be difficult for you because you need FOIL to learn conjugates. So a times a first, and then a times negative b, which would be equal to negative ab, and then b times a, which is the same thing as a times b, which is ab, and b times negative b is negative b squared. Since you have a negative ab here and a positive ab here, these two would cancel out, leaving you with a squared minus b squared. To apply that, we would want to get the squares of both of these using that. So if we have a equals 4 b equals root 2. If we look at this one, we already have a minus b. So we have a minus b. That means we would have to multiply the denominator by a plus b, which would be a plus b equals 4 plus root 2. So we multiply the denominator by that, but we'd also have to multiply the numerator by that, because what you have to do to the denominator, you also have to do to the numerator. So let's multiply by what we just got, 4 plus root 2. What we did to the denominator, we do to the numerator. So this is where FOIL is going to be kind of hard. Since we already know a squared minus b squared equals this, and a is going to be 4, b is root 2, 4 squared minus root 2 squared is equal to, 4 squared is 16, root 2 squared is 2, minus 2 equals 14. So we just got an integer inside our denominator. That's really, really good. So we'll leave the 14 here, and then the fraction bar. Now we have to use FOIL for the numerator, which is going to be tough and tedious. So let's start multiplying. 6 plus root 2, I'll put in the parentheses, times 4 plus root 2. So you do the first one. 6 times 4 is 24. 6 times root 2 is equal to positive 6 root 2. Root 2 times 4 is 4 root 2. And root 2 times root 2 again would be equal to just a regular 2. So combining like terms, we get 24 and 2. 24 plus 2 is 26. And 6 root 2 plus 4 root 2 is 10 root 2. So that would be your answer, but you could simplify it even further. Now I'm going to erase this to give us a little bit more space. If you look at all the terms inside the fraction, we can see that they're all divisible by 2. So if we took the 2, divided the numerator by 2, and the denominator by 2, we'd simplify it further. 26 divided by 2 is 13. 10 root 2 over 2 is 5 root 2. And 14 over 2 would be 7. So that would be your final answer. I know that may be tough, but if you learn it, it'll be really, really worthwhile. So let's move on to the next problem. In this case, we are given a plus b instead of a minus b. So we know that a equals 1 and b equals root 5. Since we know a plus b, we need to multiply by a minus b. So in this case, that would be times 1 minus root 5. Ooh, that's a 5, not 2, sorry about that. What we do to the denominator, we do the numerator. And this time, we're just going to do the same thing as we did over here. So 1 squared, let's find the denominator, minus root 5 squared. In this case, that would be equal to 1 minus 5 equals negative 4. So our denominator is negative 4. Let's move that right here in the fraction bar. I'm going to erase this to give us more space. And let's multiply the numerator out. Now this one looks like it's going to be long and tedious. Plus 2 root 3 times 1 minus square root of 5. So let's multiply 3 by 1. It's 3. 3 by root 5. Oh, 3 times negative root 5, so this would become a negative, because that'd be negative 3 root 5. 2 root 3 times 1 is positive 2 root 3. And 2 root 3 times negative root 5 would be equal to, since there are two numbers inside the radicals, we multiply them, and we get negative 2 root 3 times 5 is 15. So if we look at it, can we simplify it like we did over here? There are no common factors between all the numbers, so we can't. And these can't be simplified any further because they're all different terms. So I think I'm going to rewrite this. That's going to be our answer. This over -4. Now that doesn't necessarily look like a pretty number, but since we don't have a square root in the denominator, we are good.